In this demo, we will implement dependency injection in Java from scratch. We'll start by creating a new project. Let's call it Dependency. And we are going to handle dependency injection for a very common case. Let's say that we have in our test scenario a service which usually starts by defining the contract for the service. So let's say that we have a contract, and for this contract we only have a method which returns nothing and it's called do something. When a client wants to call this service, usually it will need to use a factory to get the actual implementation of the service, because in most of the cases this service it's an adapter which is implemented for different providers. Okay, in this case we'll have a client application, and this client will have a reference to the service, I said. In order to get this service, the client will call a factory. So we have, let's say, a static factory which will have a public method that will create a service. Let's call it getService. Although it's not getting the service, it's actually creating the service, and will return null because we don't know what kind of service to create. Okay, so the client, in order to invoke the service to do something by calling the appropriate method, we'll need first to have a method to get the service by calling the factory and then asking the service to do something. So first it will call the factory to get the service, and then having the service created, it will call it to actually perform the work. Okay, in this scenario there is a drawback, mainly because the factory needs to be known in advance by the client. So the code won't compile if the client doesn't know the factory. Therefore we need to implement the factory, which might also mean that we'll need to know how to create the service inside the client, because the client will have the reference to the factory and the code of the factory should be implemented together with the client. This is actually a strong limitation, because although the factory might decide which service to call using some information which can be extracted from a text file which is configurable, however, this logic is inside the factory, so it's known by the client in advance. The idea would be to totally decouple those implementations of the client and the factory by using some insertion points, some markers like annotations that will be placed in the client model to require some injection at runtime. So we will be able to have different contexts and different logics to inject the services with different factories that are unknown by the client at runtime. That's the point and the most important benefit of dependency injection, to be able to completely decouple the client and factory implementation. Otherwise, it's just an architectural pattern that it's of course brilliant, it's better than using factories, however, it's still a pattern, and in most of the cases a simple factory will do the job perfectly. Okay, let me show you the idea. Let's say we have a framework in which we want to implement the dependency injection. We are going to do it from scratch, because in this way we will understand frameworks like more complex like Google Juice. Okay? We'll start by saying that instead of calling a factory to get the service, we want to have we want to have an annotation that is placed on this field. We are going to implement dependency injections only for fields and not for other stuff like method parameters or constructors or whatever, because we are not intended to do also a demo on aspect-oriented programming and interception of the methods. Okay, so we'll start by creating an annotation. An annotation is a special interface. We will call it inject. Okay, and this annotation may also be used not only at compile time, not only on runtime, but also at compile time. So we'll have to specify the retention of the annotation. The retention, in our case, it's runtime because we need to have it in the metadata of the binary. Okay, we also have to specify the target of the annotation, which is an element target, an element type, sorry, and we want to be able to apply this only on fields. So we select the target to be the field. Okay. The next step, sorry, is to define a way to configure the mapping. We will need to specify how the client will access the service. For that, the idea is to have an interface and to provide a container, like a placeholder for the configurator, to call a generally configure method to load the mapping. For that, we'll define an annotation, which is, an interface. I will call it module. And this interface will only have a method that will configure the module. Okay, it should be called configure. This method should get as parameter a binder, an object that will store the binding, and I will create a binder class. Let's call it the parameter here, binder. I will say that I want to create, okay, it's not resolving it, so I want to have a resolution for that, which is create this class. So the binder will have to store the mapping between references to be injected and actual type to be used. So inside the binder we will have a hash table, okay, it's a private hash table, that will map a different specific type to a real one. But the idea is to be able to configure the model by using the natural language, like by saying I want to bind this type to this type. Okay, for that we will need to have a class that will be able to have methods to implement the action to. Okay, we will create for that purposes a binding. This will store the bindings, and I will instantiate the binding later on when we will be able to do it. Okay, because now the class is not really created. I will create the binding, the missing class, inside the framework package, and I will come back here inside the binder just to instantiate the hash table, now that the class is created and the compiler knows about it. Okay, the binder only provides a public method which will return a binding called bind that will say we want start this type to bind to a specific implementation. Okay, so the bind method will create a binding from our framework and will put this binding to the corresponding type in our bindings hash table. Then we'll return the binding that has been created. Okay. We also need a method to get a specific binding. Let's call it get binding by a type, and this will actually return from our bindings. Okay, not the bind method, but sorry, from our bindings we have to get by the type the corresponding binding. Okay, so the idea will be that the user will define a module that will load the bindings, which means that we'll call the bind method to start assigning a type to a current implementation, and this will allow a natural expression like bind this type to a current implementation. Therefore, the binding should contain a method to and should store the type to which we want to bind. Okay, so we'll define just the type to what we're binding. We'll have a public method called to, which will return void because we are not going to apply a different action after we call the to method. And this will be actually the target of the binding. It's the type, okay, used as the action implementation for the reference. We will just store this information and we will create a getter to return the type. Okay, this one should be called getType, and it will only return the type from this class. This is the structure we are going to use to actually define the bindings. But the most important component is the injector, the component which is going to actually instantiate a class and resolve all the dependencies. Let's create this component and then continue the testing, the demo. Let's call it injector because it's going to inject the missing dependencies. This injector will need to have a binder. We are going to create this injector by using a configuration module. So what we are supposing to do here is to create a binding. Okay, let me spell it correctly. Okay, after we create the binder, we only need to call the module to configure this particular binder. Okay, and that's all. So when we create an injector, we use the configuration module, we create a placeholder for the bindings, and then call the module to configure that placeholder. The injector will be called to actually get an instance of an object. So we will have a method that will return a generic type t, which will be either the object that has no dependencies to a binding context, that has no injections to be resolved, or an object that is actually supposed to be modified. Anyway, we will return a type t, and this will be a instance method that will have as parameter a class type of t, just to allow us to instantiate the type. What we are going to do, we are going to create an object of this type. So we'll define a variable and we will call the constructor without any parameters of the type. Now it's saying that we are first not returning the value, so let's return the object, which is of type t, and of course let's resolve it by throwing the exceptions when we instantiate the object. Okay, so what we are supposing to do with this getInstance method? First, we have to create the object. Then we have to see if among the fields of this object we have some fields annotated with inject attribute. Therefore, let's iterate with all the fields, and for that we have the metadata class for the field, which is from Java language Reflect. We'll just iterate through all the declared fields, okay, not by name, but all the declared fields of the type. What we want to achieve: if the field has the appropriate inject annotation, which means that the get annotation of this type is not null, then this field should be injected. What we want to do is to set the value for this field on our object that has been created to the corresponding instance which should be delivered by the binding configuration. First, in order to be able to set the value of the field, we need to see if the field is accessible. For that, we'll just call the method isAccessible on the field. We'll store this information, and in case it's not accessible, in this case we have to make it accessible to be able to set the value of the field. In the end, after setting the value, we'll have to let the field with the same accessible status that was before. So if it was not accessible, then the field should be marked as non-accessible. In the meantime, we will have to set the value of the field on this particular object to be a specific value. And we will create the value as being an object. Okay, first of all, this value should be an instance of the actual type that the user intend to use it for the injection. But the idea is that this value as an object might also have internal injection dependencies to other type of objects. So we need to call sort of recursive method, mutual recursive, that will resolve those dependencies by also calling the get instance of that type. So we will create here a private method. This method will create the dependency as an object. Let's call it get dependency. And we have to create an object of a type given by as a parameter. So what we want to do, we have to get the binding from the binder by calling the getBinder method by type. We are supposing that this type exists, so we won't do any checking on it, but just we'll create an object of this type. Okay, so the binding has a method getType. This is the type that we will have to instantiate, but for that, in order to resolve the inner injection dependencies, we are going to call getInstance with this type. Okay, so as you can see from here, this method is throwing some exceptions that we are going to throw outer, and here we will have to call the method getDependency, and the type of the object should be the type of the field. So we will call getType on the field to get the type of the field. So what is the logic of this? When we want to create an instance that will have injected the dependencies, we'll get the type of the instance, okay, and we'll create an object of this type by calling the default constructor. We'll iterate through all the declared fields in that type. In case the field is annotated to be injected, we'll see if it's accessible. If it's not, we'll make it accessible. In the end, we'll restore the accessible state, and we'll have to create a dependency of that type, of the type of the actual type of the field. Okay, in order to get a dependency, we have to ask the binder configuration which is the type that actually should be delivered for this field. Okay, and in order to resolve inner dependencies, to inject those into this object, we are going to call the get instance with the type of the binding. So in our case, if we will have a mockup service, we'll ask the injector to get an instance of the client which has a dependency to the service, and when this iteration will encounter the field annotated with inject attribute, it will ask the configuration to deliver the type for that. So for our service, we'll have, let's say, a mockup service as implementation. And then we'll ask again the injector to resolve that object, which will create a mockup service, and in case the mockup service has inner dependencies that need to be injected, then that dependency will be resolved as well by calling the get dependency, and so on. So our framework is able now to handle inner dependencies as well, and to inject those with the actual type. Okay, what we need to have here, we have to get rid of this because we are not going to call directly the factory. We don't need to instantiate the service, hence it will be created by the framework, but we will need to use the inject annotation on the service. Okay, and of course we need to create an implementation from the service. Let's call it mock service. It's a mockup. This will implement the service interface, the one from test. Okay, let's say that we are not doing anything, but the idea is that we are going to show something, so we are just output to the system account, just doing nothing, okay, and we have to create a module. Let's call it my module. This will actually implement the module interface from our framework, and as I said, we are going to make it in a natural way. Like for instance, we want to configure the binding to bind the implementation for the service interface to the mock service. So what we have to do is just implement the logic inside the module that will configure the binder. As you can see, we are providing from the injector an object that will store the bindings, and as you can see as well, we have a natural way to do that by saying I want to bind this interface, either class, to an actual implementation. Okay, so we are going to create a program to test it, and we want to have a main for that. Don't need to comment on it, but we will need to create a client. This time the client won't be created directly by calling the constructor on it. Rather, we will have to create a new injector. Okay, so first let me create an injector, and I will create first a module for that. I'm going to do it explicitly. The module is defined in the framework. We want to create a module of type myModule. I will provide this as a parameter for the constructor when we create the injector. And when we create a client, instead of calling the constructor for the client class, we are going to call injector get instance. And we want to have a client here. Since this is a method that might throw exceptions, we will have either to treat these exceptions or to throw by the main method, but we are going to surround them with, not synchronize, but try catch. Okay, let me do it right this time. surround with try catch block, and will output the stack trace of the exception in case we'll have one. After the client is created, we are going to call it to do something by calling inside the service. I'm going to run this as a Java application. As in the end, as you can see, it's injecting the service. So what's the idea with dependency injection after all? As you can see, in case we have, let's say, a generic service like an adapter, and for this service we need to call a factory to create an actual implementation of the service, like for testing purposes or for other implementation. We'll need to, in the traditional way, we need to have a factory, and that factory will need to have implemented the logic that will say which implementation should be delivered for this type of object. So our client in general will need to know somehow how to create the service. But in order to decouple the implementation of the service from the client, we have to hide somehow the factory logic. Okay? For that, we mark the service as a reference that need to be injected, and that's all we need to do in the client part. So all the modules that will need to be to have injections inside, we'll only have to specify which fields need to be injected. Okay? The second step will be to define a binding module, which is actually implementing the logic of the factory by saying which implementation should be delivered for this type of fields. As you can see here, our demo only handles simple mappings. We have no filters on it. We are not able to decide, depending on the type of the class, which implementation should be delivered. In other words, we will provide a mock service for any field of type service, regardless if it's inside the client class or in other class. But you can imagine a more complex scenario for defining modules in which this binding to a specific class should be filtered. So in order to do that, instead of having an endpoint here in the binding class, which is the to method, which returns void, we'll have to define a new class that will handle the filters. So we'll return from the to method this type of object that will have additional methods to apply filters to our binding. Okay? So the idea is that we define this module which contains the logic how to bind from this type to that one, and when we want to create an object that has dependencies to be injected, instead of calling the constructor, because we are not using aspect-oriented programming to intercept the constructor and to do it in a transparent manner, we'll have to define an injector before and call this injector to get an instance of this type, which means to resolve all the inner dependencies. Okay? So this injector will rely on a module to configure the bindings, and we can pass this module as parameter in the constructor of the injector, and then we'll use the injector to actually resolve the dependencies. As you can see, dependency injection is a more efficient way to handle the issue of object creation by factories, because it addresses the problem of decoupling the client and the service implementation, and also from the factory. So the main advantage of that is that we can easily replace the logic of the factory without having to modify the client, I mean the already implemented modules. We only have to provide a different binding module that will handle in a different manner this relation between the consumer and the producer of the service. In general, this has benefits in frameworks that are relying on singletons. For instance, if we have a more complex environment in which some specific services like validation of objects, like layouting the objects in the interface, those services are provided by specific objects. In general, before dependency injection, we can have singletons that are accessed by all the components in the platform. But in order to replace the actual implementation of the service, we'll have to modify all the classes that are calling the singleton to get it. So by having dependency injection, instead of calling directly the factory or the singleton, we are able to maintain the code and to specify where we need to place those objects created by factories. So it's a general way to handle and to resolve as late as possible dependencies to objects, not by calling factories directly, but by defining placeholders, injection points, as you may see here, and then have a generic way to deal with that. Thanks for watching this demo, and I hope we'll use dependency injection as much as possible in your code.